All right, guys. So welcome to today's session, the Wednesday session for Introduction to Data Analysis. Introduction to Data Analysis is where we try to understand the different philosophies around data analysis. Of course, we're learning this using the Python programming language, and Python is an object-oriented language where where variables are the order of the day, and variables hold data types, and these data types are Python objects. Of course, go on to we go on to try to abstract these objects into real life situations or real life scenarios. These real life scenarios include data collection of our everyday activities and how we try to use statistical methods or logical techniques to extract information from them. But basically, we're looking at the basics. So we're going through the basics and we're looking at collection of data, the philosophy around it. We're looking at the pandas data frame, the philosophy around it. And at the same time, we're trying to be intelligent with how we do these things. Let me give you guys a sense of what is coming in future. Part of your assignment, your major assignments in future, assessments in future is going to be you writing, you're going to write a report. The report is going to be in form of an article where you pick up a data set, where I'll share a data set, and then you guys would go ahead to ask questions about this data set, then go ahead to write an article about it. And in the article, you're expected to, tell your story as a data analyst would, right? There's not going to be, you're going to share the codes one way and you're going to share the articles. And the articles, you're going to upload the articles into platforms. So, we're going to upload articles into Medium. So I'm going to share my screen so that you can see where these articles are going to be uploaded in future. So bear that in mind. It's going to be a thing, right? So there are different places you can upload your articles. You can upload your articles to Medium, medium.com. So, if I were you, I'll go and open a Medium account, or you can open an account, or you can upload it Substack. Hey, you're gonna write proper stuff, Yes, you write proper stuff. You write it, and that will be what I'll document. That's what I'll use to assess you in the end. And you're going to upload them live. They're going to be live and all that. So this Substack notes, you can start writing in Substack. So you upload to Substack, and yep. So places like this, or you can even choose LinkedIn. The place, it must be a public platform, and you upload it, and then you share amongst your colleagues, show them what you're doing and all that. I'll look at that. So I'm going to curate a scoring, scoring, how I'm going to score it based on how you do all this stuff. So it's all good for you to check out the different types of stuff. Check out, yeah. Also, have you guys heard of Steers? Steers. Have you guys heard of Steers? Look at that, Steers. Steers.co. Yes. Right. This is it. I hope this is it. Yes. I haven't, but I don't have much content. I have, but don't have. Yeah. So, I'm just saying, if you want, you can sign up to them. It's a platform. They explore situations. They explore things in Nigeria. Stix is not a free platform. Yeah, but they have free. They have free stuff, so you can see all that. They do write-ups. Yes, you can have a free account, but limited to, if you get a free account, you're limited to some articles, right? but you can just sign up for free and read up what they do. I think they have really, like see this, the track monthly price changes. Like these things are really cool stuff. Yeah, but again, it mustn't be you mustn't pay for it, but I think it's a very cool place. It's a cool place to learn stuff. So you see that they have stories. They're not stories, rather they have articles. It's cool. You can see the way they ask key questions. For instance, here they're asking, what is Transcorp PLC's financial performance? How will the changes in the power sector make generation companies more profitable? And you see, one cool thing about Steers is how they write and they use statistics. They share data. You can see this. You can see them trying to, So one cool thing, they do a lot of they write articles using data, and it reflects a lot of statistics and stuff, right? So stuff like that. So it's really cool stuff. They have their free to read. So if you click on their free to read, you're going to see their the if they have anything that is free, you can pick up on that. A lot of premium articles, but there must definitely be something free. Or you can also sign up to get newsletters from them. But the whole idea about signing up on this to get their free articles is so that you can learn to write articles yourself, right? And it's really cool. So it's borders on a lot of stuff that's cool. How can government protect consumers while encouraging innovation? So it just gives you a sense of how you can and do stuff. How you watch and get to read. Oh, I see. It's not free to read for me because I'm on a premium plan. But I mean, but yeah. So just sign up. You are going to get free articles from them, so you can read up on their free articles, and you're going to see. Yeah, but it gives you a sense. You can see a sense of how you can write articles, and then, based on the data you have, based on the analysis you have done in your notebooks, you can write articles about them. So this is just about what you're going to be doing at the end of, as part of your major assessments at the end of in alt school, which would make a lot of sense. To be open to the world, you share it on a platform like Substack, Medium, or LinkedIn. It's going to be classic, right? See that? Yeah. See a lot of stuff they do. Oh, look at that. Average inflation rate across Nigeria. So different states with different inflation rates, food prices, major cause of inflation, stuff like that. So yeah, really important stuff. So try. Also, if you are going to be a data analyst, you should have a lot. You should read. You should read a lot, because it gives you a sense of it gives you range. There's something called range. There's a book called Range. You guys should read, please read. There's a book called Range that it's premised on the fact that if you read a lot, you build some you build some skill sets. It's like apportioning different skill sets. That it makes you highly competitive. It gives you a competitive advantage, right? So yeah, so that's one. So I've given you guys an info into what's coming in future. So when that time comes, you're not going to be like, oh, Pablo just came and threw it on us like that without warning. So right, so you guys will do a lot of write-ups and make a lot of sense. I'm still thinking of the data set. I might ask you guys to maybe get your own data whatever it is you're going to write must not be so some of it mustn't be real. It's just you testing, writing up stuff. So you could collect a data set and then you can do an analysis. You can ask key questions. Then you go on to write your what you found out about it. So it's a lot of sense. Makes sense, right? You guys like the idea, Abby? Do you guys like the idea? Cool, right? Yes, no. Alada knows what's up, man. Mm. So yeah, so let's do that. So next, let's get into the order of the day. I want us to go data. Um, mhm. Then when we are done, work. Oh, did I jump too fast? Yeah, when we are done working on our own data, we are going to introduce. We're going to introduce something new. It's not something new, but something you guys already know. Um, I'm wondering where we're going to have that. Where are we going to have this new one, this new stuff that we have done? Where did we talk about? Yeah, we talked about series and all. So we're going to be talking about them here. So I'm going to introduce NumPy. Sorry, how is it confusing? Just type, say why you think it's confusing. So take your time and say, oh, this is confusing. Why do you want to confuse us? Just let me know. Mhm. I have introduced pandas, so I'm going to also introduce NumPy. So yeah, here we're going to do that. Introduction to NumPy. Right. So that's that. So that's going to be the second part of what we're going to be doing today. And then we're going to also look at some philosophies too. So we're going to look at some philosophies in terms of in terms of we're going to look at some philosophies in terms of pandas and NumPy at the same time, but we'll introduce them and talk about a few philosophies. So it's basically pandas, NumPy, and our own data today. So let's get started. Let's get started. Now, in our own data, let's just look at an update of what we did last time. So we have collected our data, our Gmail data, and we've read the data, we've picked it up, looked at the data, all the keys in the data, transformed the keys into CSV files, and then we've read it. And then of course we looked at our data, and our data looked all over the place, right? If you come over here, you see our data was looking all over the place here. Then we started to do some refactoring, right? Then one of the first things we tried to do first was to transform the date column, because one of the first things you will get to do when you collect data is you're going to look at the data, And when you look at the data, the first question you're going to ask is if the data has a problem. And by looking at the data here, you can see that we have subjects, which subjects are like objects, or they are like strings or objects, depending on the wants or how you want it to be. Then they will look at from. All these things are basically quote unquote objects or strings. But when we look at date, a date is not an object. A date is a date, is a date time object, basically, but it's not an object. It's often put out as object because Pandas does not know what it looks like. Okay, while we are at it, right, Oladayo, please send me a screenshot of the place you downloaded the data. Let me look at it. Let me see what it looks like. If you know you've not been able to read your data, I need to see where you downloaded it. Let me look at what we are dealing with, because I'm guessing it's a simple download, right? Then let's be sure that we take that one out of the road. So while we are at it, please, here's where we are. Yes, I see you, Lucky. Right. So let's get that one going. So at least let's know. But I need you guys to pay attention to what I'm doing here so that you can get a sense of the kind of analysis you can do. Also, there's something I need to explain to you guys when you're learning. I call it structural analysis. So I got this idea from a book I read some time back, where if you're trying to learn something, you kind of take ideas, you lift ideas from one area and use it in another area. It's kind of what you do when you get to Stack Overflow. You know, that's when you get to Stack Overflow. By the way, do you know that Stack Overflow has a data science part of it? There is. I think it's called Data Science Exchange or something, because Stack Overflow is like an exchange. But yeah, look it up if you can. So what was I saying? So when you're doing structural analysis, you tend to read from other places, then lift the idea and use it. Your ability to do that is going to be is critical to your development, especially when you're learning. So it helps. So a lot of the resources again that I'm sharing, or the things I'm sharing here, you can now take some of them and pick up a data set and say, okay, if I'm in a situation of trying to look at a column, how do I refactor that column, or how do I maybe convert the column and features into something else, right? So really cool stuff you can do. All right. So please let me see. Start off, Olada. Let me see. Just go to your download folder, get a screenshot of what you have downloaded. Let me see what it looks like and what you are reading. Or basically, I need you to show me what you are reading in your directory. So let me be sure that we are reading the right stuff first. All right, then back here. So when we read our data set, which is containing our which contains 6 features, subject, from, date, to, label, and thread. When we look at it, we try to make sense of it, and we notice that the date column does not make, you cannot have a date column and it's an object. So what did we do? We converted the date feature to a datetime format. And Pandas has datetime format. We use the default datetime format here. And then, of course, you get to see how you can make changes to a data frame. You can choose to make changes to a data set, features in a data frame, right? You can do that, and then that data frame, just everything that is in there will now be in a different one. Can now be applied to that feature you're trying to play around with. So what we're trying to do here was look at the date and find a way to convert it. And we used the Lambda function. I explained the philosophy around the Lambda function. So it's an anonymous function that you can use to apply a function to a line of code. And then we're able to convert this. So again, when we read it again, using this, the concise summary, you can see that the data type is now different. And then if you look at it, you can now see that there's been a different, the way the data is read is different. The date has now changed. Then we converted that data frame into a raw data set. So it's a thing. You can do that. Then we started to look at refactoring. So refactoring is basically looking at your data and then trying to change the way your data looks. We looked at the from table, and the from table is important here because it has the emails that you've received, right? And it's important to know that those are the emails you've received. Also, somewhere you have emails you've also sent, but so we refactored it. Why did this happen? Yeah, this is not supposed to. Okay. I have run it before. No, this isn't supposed to happen. Let me restart it all over again so that it looks, we can tell from the very beginning what we're doing, right? Because that did not just seem right. So I've imported the data. We use the mbox file for the ones that some guys are struggling to open. Please Olada, send me a screenshot. Then we were able to take, okay, not here, but I said send me the screenshots in your download folder. You're sending me the ones. It's here. I want to see. So which one did you do? You did the takeout. Which of the takeouts did you use? The first or second takeout? The one that is in the zip folder. So, but whatever the case is, I would have loved to see it in your download folder where it is. And no, I'm amazed that you're having issues with this, but yeah, it's the notebook I'm reading the data from. Okay. I just want to see the file itself, but yeah, and I want to see it in your Finder. Yeah. All right. So so what we did is we used an mbox, which is a method to read the data we have, and then because the data we have is in keys, then we read them out, right? Like it's like in a dictionary format, so read them out. There are keys in them. So all these keys that are a part of what is in our data, in our Gmail data, which basically shows us our messages in the different classifications we have them, will be pulled out. Again, it's a form of a transformation, but you see them there. So we now have columns of interests, subject from to, right? And to do that, we want to take the data and convert it to a CSV file. We import a CSV. We import the CSV package, then use the with statements and the open, quote unquote, the open function to write the files inside. So we write them out so that they can now be, in form of a CSV, and so we can read it easily into a data frame. So that we basically wait for this to complete, and when it does, then we read our data set. Once the data set is ready, we read it into a data frame. Then we read the first 5 rows, and then we'll see what the data looks like. Then we'll see our email in its raw state. Now, so when data is in its raw state, it only makes sense that you try to clean it up. You try to find a way to make it readable so that it can be analyzed easily. And so that's what's happening here. It takes a little bit of time, but yes, it is done. So you can see our data. Our data looks different. It's okay, but looks all over the place. If you look, if we just focus on one of the rows, you can see how this looks. So we have to pay close attention to each to the info, the summary of the data frame. And you can see that some of the data types are objects, but they shouldn't be objects. So we converted the date time, and here right after the conversion, we now have a date time object. So that means with the date time object, it means that you can read, if you can read the data like time series data, but that we'll talk about later. Right, and then can we have an example using lambda function to change an object to a string? Change an object to a string. Yeah, we can. So let me see what data set are we going to? Yes, so we can. Let me see. Let me go down here. So let's look at this as a challenge. So we no, this isn't ready. So let's read this Titanic data. Titanic underscore data. And we have pd.read CSV. Right. Then we use train. So this, and we have this. Now let me see what do we want to do now. Let's say we want to convert. So we look at this. We look at this, and then we say, okay, we say Titanic data dot info. When we do that, we now have all this. So we see like ticket. Okay, ticket is an object. So we see something like what is an integer? We see age is floats, right? So now let me see. Let me just see something here. Let's see. Then let's hold on a bit. I want to open this. So let's see. Trying to see. Okay, how would I look at this? Let me get a sense of what I'm going to do. So convert. All right, so let's see if we can convert the age. Let's see if we want to convert age into want to convert age into a string. So let's say we'll call this Titanic data, and we're going to create ourselves a new let's call this age underscore str. So that's going to be our age data. We've created it newly. Then what we're going to do is we are going to say Titanic data. Then we would refer to the Titanic data age. Then we are going to apply lambda to it. So let's say lambda, and then we're going to say x. Now what we want to do is we want to convert something. So we want to convert it to a string. And to convert it to a string, we're just going to say, what do we do? X, can we say, how do we convert stuff into a string? Let me see. Convert column data type string, pandas column data type string. Column data type to string, yes. Oh, what's that? Okay, so this is how you convert it to string, right? Okay, so I'm trying to think of, so this is it dot as type to string. So basically I come back here and say X is dot as type to string. Let me see if we can put that here. So let me see. Let's see how I write that code. Let's say X. So let me see. So to convert to string, we can say X dot. So because it's the date itself, dot as type open bracket. So that's what I should do, because to convert that is as type, then we put string inside. So let me see, str. Because once you are trying to convert an as type, you put str inside. Yep. And so that should convert this. That should convert this. Oh, the float has no attribute as type. We could basically say, we could move it to say str, which is string, open bracket. Again, that's another way I could look at it. And then if we pick this up here, we look at Titanic data dot columns and see we should have h underscore string. And let me see if we say Titanic data dot info, we should have h as an object. So yeah. But you think that's a long process? Why do you think it's a long process? Oh. Do you have a short process? Of course, there could be a short process you're trying to use, but it's because you have, once you're writing code, you have to take time out to figure what it is. Is there a short process you feel? I feel like there's a process where I basically just call on the data set and then convert it just like it is here. But Rabiu asked, how do you use this thing? Did you read Rabiu's question? He wants to have an example of using a lambda function to change an object to string. You see that? So of course, as type works, but now he wants to say, okay, if I use a lambda function, how does that work? So that's what I did. Yep. So So basically, Rabiu, that's just what you do. So that's what you do. I mean, I don't see why you should have a problem, Oladayo. I don't see why. I don't see why you should have a problem, though. Right. So, Rabiu, does that make any sense? Do you see how that works? So, with 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 age_strings, we have converted it. We have created a new one, and then it's a string. You can see that in here, it's now that. So that's just how that works. So I mean, Lambda function helps to do a lot of stuff. Again, when I said Justice, when I talked about when you talk about Lambda functions, you get to see that sometimes you have created a function and you want to apply it, and then at the same time you want to ensure that when you apply it, it follows a certain routine, or you want to use an if statement there. You have a function, you want to use an if statement, that works, right? But just to show you how Lambda function is, that's just like the way it is. So works that way. So where were we? Right. So I think we were here. Right. Now, once we have our data here, I think, haven't we converted our data already? We have. Let me see. Yes. Now, and then you can convert your data to you can take a data frame and convert it back to CSV. Now, so again, we are looking at the data, our from data, and we see that it's all over the place, and we just want to extract just the emails. We imported regular expressions, and then we created a function. We created a function that extracts different tags, and it takes out different tags, or sets or finds in the midst of all the tags, finds out something that we're looking for. And here we wanted to extract this news, all the email addresses, and we use this to get that. At the end of the day, we now use the Lambda function to apply it here, and we did, and our data is now different. Again, the next thing we wanted to deal with is to look at the label column, and we see that the label column has a certain relationship with the from column. So whatever is in the label tells the kind of what email you received. So if you had an email that was sent to you, the label has that, and it has your email. So the whole idea was to refactor this data and then ensure that any information that comes from your email is your sent, and any information other than your email is in your inbox. And again, you can see Justice, you can see a use case, a proper use case for a Lambda function. Pretty simple. So, and also, Rabi, you can also see, I can also understand why Justice feels it's a lot to go and start using a Lambda function for what you can basically use as type to write. But at the same time, you can also understand that the Lambda function can be applied using that same way. But again, look at it here. We apply the Lambda function on the from column, saying anything sent is my email, anything else is an inbox, and that is applied. And again, now we now have inbox, and we have the ones that are sent. So again, you see how the data is now looking as we proceed. Then, since we have done all that, it doesn't really make sense to look at the two column. The two column doesn't really, is needless. Now, again, I want to remind you guys that when we are doing all these things, it is for you to understand that when you have your data in future, you can always come back to all this that we've done, right? And then try to think of how do I clean up my data because I want to write an article with it? I want to do a report. I want to do my final data analysis report. And then you have a data set and you look at the data and the data looks in different ways. Of course, you can do a lot of analysis with it, but you can do a lot of searching online and finding different ways to get that done. But again, I need you guys to look at all these resources and start to think, oh, there are different ways I can look at this, what this guy has done, and I can make sense out of what he has done and try to do something with my own. So finally, we look at the drop column and the to column, and we drop it because we literally don't need it anymore. And so now we just have 1, 2, 3, 4, 5 rows of data. So this is where we were, and this is where we'll be taking it out from. Now, there's an interesting thing about our data set. Our data set has a certain feature which is dfs.date. Yeah, dfs.date, right? Then we look at the head column and then see if we can look at it. So you can see that we have a timestamp, basically a timestamp which tells us this is it. Now, but there's a thing about this timestamp, right? And it's important that we try to understand it. When you receive your emails, something happens when you're receiving your email. Depending on, so let me just, a little bit of digression. There are different data centers that receive your emails and send it to you. So your emails are domiciled in different data centers, and these data centers could be in different parts of the world. As of today, I don't think Google has a data center in Africa. I don't know. They might have what I call, I don't think they do. I don't know if they have any in South Africa, but if they do, still makes the point. So sometimes when you collect your data, or by the time your data comes through, there could be a difference in the time zone for which you got your data. That is really, really important. Right. And so because you want to do an analysis, you probably want to reflect the data based on the time in which you got it. And so that's one important aspect of what the refactoring will be doing with our time data here. So we're going to do the refactoring. We're going to be refactoring that. And so we'll do this. So so how do we refactor this? Now, the first thing we're going to do is we need to import packages for refactoring. Really, two important packages are datetime and pytz. So these are two for refactoring. Right. Now, once we are refactoring data and we're pulling out all these guys, it's important for us to make sense of what this means. Right. So date time, we can also look at date time. Let's see. Python date time. Python date time. Yes. So this is it. So basically, you can see it's a datetime object that represents, see that? It's what it is. The datetime model supplies classes for manipulating date and times. While date and time arithmetic is supported, the focus of the implementation is on efficient attribute extraction for output formatting and manipulation. So this thing it has calendar, so it has all this inside of it. So you can use it to do a lot of manipulation. Second, another what we are dealing with is Python PyTZ. This is it. Again, it's a model. Look at that. Serves as a datetime conversion functionality. So again, if you have if the timing you're having is from a different time zone, this helps you to refactor it to your own time zone. So that's basically what we are trying to do. So our time zone, we want to look at the time zone we have and want to reflect our own time zone here in Africa, right? So if you are in a different country, time zone you'll be using will be essentially different. So for instance, time zone that Trevor and co will be using will be different. For those who are in different parts of the world, you'll be using different time zones. For me, I'll be using the time zone that is in Nigeria, right? And so that's because this is where I am, right? So next we want to do is look at, we can look at the time zone. We can see why it's important to look at time zones. So we can list of all time zones. So remember that we imported this guy. So PyTZ dot. So yeah, we want to look at all time zones. Get me? It has a lot of stuff. You can look at country names in this time zone. You can see, okay, you can see what this is in the dictionary format. So we can read it out like that. But let's also look at time zone. Okay, let's talk about all time zones. Now you see here we have so many time zones, and our focus should be on Africa, right? And like I said, a lot of people are in different time zones, so they probably want to use time zones that are good for them. So I will be taking this time zone, right? Yeah, for different people in different places, you'll be taking different time zones, right? So that's the time zone I'll be taking. Now, the next I want to do is, because I want to refactor it, we're going to have this called refactor. Again, all this code we are writing in the material that I shared with you guys, so you can always check them out. Right, but here's how these explanations now work. So now we call this refactor time zone. This is refactor time zone basically, and then here we look at we call this EST. Then we write time zone because this is what we want to check out time zone here, and then time zone I want to work with is the one I copied, Africa, Lagos. So for you guys who are in different parts of the world, again, remember you would use your own time zone, right? So I use this. Now, so what this does is that we want it to return, x dot it as time zone, x dot as time zone, and then open bracket, we'll now put EST inside of it, right? So what this does is that for me, it's going to return this. So I create this. Now I want us to again look at where is this guy? Look at this time zone here. Let me push it down. So I want us to look at this time zone here. Here, mine is 2023-04, 16:47, right? Now, I want to apply this time zone to the date function, to the date column. So again, DFS, square bracket, date. Then in date dot apply bracket lambda x. So now what we simply just do is call refactor time zone, then we open bracket and we put x inside of it. So what it's going to do is it's supposed to look at this time zone and then refactor it to the one that reflects Lagos. And so since I'm in Kaduna, whatever is happening, Lagos, we're in the same time zone, so that works. So what am I missing? Dot apply refactor under, okay. Lambda. Right. So now again, let me take this guy so that you guys can see if there's been any change. So can you see there's been an hour difference change? So you can see that an hour difference change. So that means if I was analyzing my timing, it would have been fun because earlier on it was using this universal time, this one here. So yeah, so you can see the difference, right? So again, if you guys are in, thank you. If you guys are in the different part like South Africa or elsewhere, if you do the refactoring, it's going to take it to your time. Again, what I need you guys to understand is as you're picking this up, think about yourself being an analyst and data that was collected was maybe email data or data that has time series, that has time stamps to it. And then you have to analyze it based on the situation or based on somebody's location or based on the location which you're trying to analyze. So that's really important. That's really, really important when you are doing this. That's the part called the structural analysis. So now, so we now have a date has been changed. So if we look at DFS, head, open just 3 of them, you can see that everything is beginning to look really cool from date, label. It's really beginning to look cool. Now, I also want to show you another thing that is really important. We now have, you see that we have a timestamp, and you see this timestamp, it does a lot of stuff. Inside here lies year, this is the day, and this is the month. So this is April, this is 4th of April, this is 5:47, and basically this definitely might be 15 seconds in 1 hour. I don't know what that is, but it looks to be that way. Now, what this means is every time you're dealing with a timestamp, which is a date format, there are so many opportunities. For instance, we can convert we can convert to days of the week using the date column. So that means this is actually a day of a week, see this day. So if I was to come here and just click, maybe just say calendar, right? And then, we just open like a calendar, and then we're looking at say we're looking at April 4th, right? So you see that April 4th is a Tuesday, right? That's April 4/4. Yeah, that's what it is. It's a Tuesday, right? Now, what we want to do is, how do we extract time, that from, so we can create DFS, and then we'll call this day of week, and then we're going to extract this from the dates, and then we apply using Lambda. Right now, and Lambda X. So now Pandas has a day underscore name feature. Pandas day underscore name. That should be a thing. Yeah, so look at that, day underscore name. So what that does is that it returns the day, with a specified locale. So if you use that, it's going to return this. See that? So this is the thing. So with that, you can basically look at any code you have created depending on the date, and then find that very date. So with that, we're going to have x.day underscore name. Yep. x.day underscore name. Yes, x.day underscore name. So what this should do is that it's going to take all the days, which is, like, for instance, this first guy, it's supposed to be a Tuesday, and it's supposed to put it in here. So that means if I do DFS head, no, not DFS head. Let me use this I want to extract dates, and then I want to extract day of week. Do that so that I can see if it actually looks like what we have worked with. And then I want to check head. I want to see the first 5 rows. So yeah, look at it. It's a Tuesday. It's actually a Tuesday. So right about that, and the 4th is a Tuesday. And if you look at the other ones, if you look at the other ones, you can see that their dates on the 9th. Again, if you look over here, go to the 9th, that's a Sunday, right? So you see, right. So you can see how all these things are set up, right? So that means at every turn, if you were to read your email, if you were to look at your email, for instance, and say you want to do a subset of your email, and say you want to see every email you received on a Sunday. So that means we can do a subset and say DFS open bracket DFS open bracket again, open square bracket, day of week. Then we're going to say equals Sunday. So what we are trying to do is bring out a subset of that. So now these are all the emails we have that I received on a Sunday. So let me just take the first 5, or maybe say 10. Look at that. So you can see emails that were received on a Sunday, and in fact, if I put it out, I'll see, you can see that is a really interesting thing. Sunday emails, for them, just Sundays. Isn't that interesting? Right. So where day of the week is Sunday, and it pulls out that. It even tells you a lot, right? You can see that for a long time, I haven't received emails I rarely receive emails on a Sunday, or even if I have, I probably have deleted them. Get me? So you can see all this, and then that means I haven't even sent an email on a Sunday. So imagine probably if I check out Monday. Okay, it's because I'm just checking 10. Oh, in fact, let me go back to Sunday. It's only 10 I took out. Sunday, let me just make it 30. Right, you can see the emails I have received on a Sunday. If I put tail, I'm going to see the first 30 emails I received on Sunday. So you see, let me see, tails. Yeah, so look at like one of the first that I received was like your CV. So it's in the 2017. It's like this, Brain Food 2021. So you can basically look at your this thing and find out and see that you have different stuff. You can see emails. As a matter of fact, if I probably want to see the total of all the emails received, so I could do shape, and I have 457 emails that I received on Sunday in my whole emails, 457, and that's why I received on a Sunday. So, which means if I check this to be a Monday, we have 773 emails on a Monday. So you can see we're going somewhere. You're beginning to think of analysis now. Your analysis is beginning to think, oh, you know. So again, that's just what this looks like. So when you get a subset of your data, because you've broken it down that way, it starts to make a lot of sense. Questions? Anybody with questions? Ooh, it's already. Okay. So yeah. Now, just as you can do that, it's also important that as it is like this, it's important that you convert that day of the week, because again, day of the week, if we check dfs.info, day of the week is a category. So you can see day of the week is an object. So it's important that you convert the day of the week a category, because it's actually a category. Right, because yeah. So again, remember that stuff, justice. So now you can see that if I want to do converting day of the week, probably would not use lambda anymore. I just basically do dfs dot day of the week dot as type and open brackets category. Pretty simple. Yeah, I have converted it to so again, you can do a lot of stuff with with your data, and we can convert them to different stuff. So and we're going to do that, but we'll just hold on here for a bit, so that at a point, let's not even hold on here for a bit. Let's finish with the time. Let's finish with all the time zones. So what I'm going to do is I'm going to just copy copy the different times. Like we can have time of day, right? We can have hour of day. Have it already written. So we can have hour of day, so which is the very hour. We can have the year. We can have the integer of a year. We'll be looking at the integers of a year, which is different from actually the year itself. You can see we can have the year. We're going to look at all of this. All this makes it easy for you when we finish doing it and we look at like DFS. Dot, let's say iLog bracket 0. And you can now see that on this date, 2023 June, 2023 on a Tuesday, 4th of April, right? It's a Tuesday. Time of day was what? 5. I don't know why it switches to this. Still do not understand that, but it's somewhere around 5. Hour is 17. It's 5. The year is 2023, and some integers that come with the very date. And then so it just kind of brings all these things in perspective. But right, so that literally is like an interesting thing you can do. Yes, you had to drop them, but you saw what it's using 24-hour time. Yeah, it is. It is. You're thinking like there could be a way we can convert it to a 12-hour date, right? That thing. I'll think about that too. Right. Also, so once we can do this, one last thing we are going to do is we are going to now convert this to a time series data. So this is time series. I'm sure time series is a huge stuff, but let me Google time series, and so that we can so it's called time series analysis. It's a huge area. It's a huge area. So is a specific way of analyzing a sequence of data points collected over an interval of time. In time series analysis, analysts record data points at consistent intervals over a set period of time, rather than just recording the data points intermittently or randomly. Time series is also a huge thing in data analysis, right? It's also used. It's an aspect of what they call it. It's an aspect of economics. I think it's an aspect of economics. If I'm not wrong, I think it's econometrics or so. So right. So time series is also huge. What do you call risk? So time series is huge. Time series now you can use it for forecasting and a lot of stuff, and you can it's in Python too, and you can use it to basically do your analysis. But to do that, you would have to convert that date time. You have to now change, just like we have our data here. You can see is it index? So you see that our index starts from 0. My own stops at 4,876 and takes one step at a time. We're now going to change this index. We're going to set its index, you get me, to date. So which means you're going to look at the date column. We're going to use the date column and set it as the index. So with DFS.head, we are now going to, these zeros are going to be removed. We're going to move this guy and put it here. Right, so this is what this is going to do. So once you do that, you now see that DFS.head now has dates, as you know, now use dates to basically analyze your data. And with dates, you can do a lot of stuff. Yes. Yeah. Oh, yes. Time series risk management. It's also a thing. right? So so now we can analyze like our, you know, our we can analyze what we have as dates. Remember, I think I don't think now with iloc, which is index location. Let me see, dfs.iloc. You know, at first we use a square bracket with zeros and all, but I think with this you can also use dates also, because now we can also use dates to also check them. So this is the thing. In fact, there is an article on Medium. There's an article on medium.com on time series analysis with Python. Time series analysis. Time series analysis. I think it's with Python. Yeah. Let's see. Time series analysis. I think it was written by a lady. I've read on that before. Time series analysis. Let's see. Time series analysis. Python. See if that works. It's a very good look at them, the different time series analysis with Python. You can basically, I think this is Susan Lee, I think so. Time series analysis with Python. I think in this analysis she did some analysis with Python. Yeah. So you can look at data sets, and then yeah, she did some analysis with it. And then she converted them, so you can see the timestamps were converted, and then you can now, you know, change the index. You can set the index. So if I check the index, for instance, if I check my index here, which is dfs.index, you can see that all my index are now, see them, they're all this way. So yeah, so I think with this, you can basically take out an index. Should basically take an index. Maybe you say iloc. I think that's what it does. No. Cannot index by location with a non-integer. Let me see. Yep. So you can do that. And I'm also thinking you can go from one position to another position, which means you can take a certain date. Hold on, let me see if I can do this. Yeah, for that, you see, with this, you can see all the dates for that. And I'm also thinking that if I decide to say, if I put this and I maybe copy, if I copy this again, maybe say I want to go from this, I don't know if it's 5. Yeah, this comes out, which is all the, yes, from the 5th, and yeah, right, dfs.lock. So datetime index is deprecated, we raise the value. So which is it? Future warning. Yeah, we'll raise it. So something of this nature, you can see that I can be looking at, there's an email for this day. So again, I mean, you can decide that you want to find your a certain day. You can see them different emails for this very day. I'm looking at this very day. Can I look at the shape? Yes, on this very day, I had 25 emails on that day. So stuff like that. So with time series, you can read through. Let me see if this is a free. If this is a free, this is a free article. So I'll share it with you guys. It's a free article, so you can read through. Try and see if you can read through and then really cool. See if you can do it. Let me pin it here so you guys see. Oh, I never saw it. Right. So right here. So that is that. So I mean, if you read through this is good. You're going to learn about all this. Yep. And then the data are there. You can download the data, and then you can really copy her code and then see how her code makes a lot of sense and how you can analyze it. Makes a lot of sense too. You can do a lot. See here, yeah, Trevor, Trevor. Let's focus. Get me so you can see that. And then you can do a lot of stuff with it. You can visualize stuff using time series and draw line charts and all that. So, right. So really cool stuff. So so yeah. So that's that for today. So let me basically let's go to introduction to NumPy. Ooh, like this part. Where is it? Yeah. Right. He has to. So what is NumPy? Aboladayo, focus to. Esther, tell Oladayo to focus. Focus. Mm, tell Oladayo to focus. You see, it's this lack of focus that made you miss out on top or being on top of the league. See that? You lost focus, man. Yeah. Right. So anybody heard about NumPy? If you've heard about NumPy, tell me what you know about NumPy. What do you know about NumPy? Okay, so let's talk. Let's do a little bit of learning about NumPy. Uh, so again, right? Python has a fundamental flaw, right? And that's how I'm going to start it. Python has a fundamental flaw. And one of its fundamental flaws, if I have to put it that way, is every time every time we are collecting data and anytime we are creating variables, what happens is Python is, manipulating the data in memory, right? So of course, data comes from different aspects and all that, different sources and all, and then you have pandas trying to do a lot of analysis and all. You have Python trying to do a lot of manipulation. And so, but that happens in different aspects. There's data, it is collected in terms of, images, it's collected in terms of, it's data is a bit structured or unstructured, right? Now, but on one side, it's easier to analyze this data in one way. It's easier to put them out as arrays. Why? Because if you put them out as arrays, they are, and these arrays collect one type, make use of one type of a data type, then it's practically so quick for you to analyze it in terms of arrays of numbers, rather than trying to analyze them as text. So what numerical Python does is that it makes up for a lot of things. It makes up for speed because your data is basically analyzed in as vectors, as like in terms like they're in matrices and stuff. They are analyzed that way. So once data is collected, NumPy transforms this data into arrays of numbers. Now for this, right, because we can just we'll write down things like this: arrays. It's not just that. Yeah, it's not just that, right? Yeah, it makes numerical computation easy. Exactly. One. But another thing it does is because of how slow it is to, because Python is object oriented. You think of the philosophy of having to take objects and analyze each object. When you set them in arrays, you just have one data type, and then you can basically read through them easily. So that's what numerical computation is. It's just computing based on numbers, and and that's just one of those ways that you can look at it. Again, yeah, Martins, you're right. Mathematical operation, in arrays. So numerical computation for mathematical operations work easier with NumPy. Right, of course, yes, Trevor, it's a model, it's a package with different methods inside. So yeah, you guys basically cut it in different ways. So the idea for now is for us to try to think of the philosophy around it. Now, because data is being manipulated in arrays, or basically numerical arrays, it makes for efficient storage. It also makes for speedy manipulation. So speedy manipulation. Yeah, and because imagine that as we proceed, we're going to be looking at data in different ways, right? We're going to be looking at data, like high-level data, as we keep going. Arrays become a very, very important aspect of what we'll be using, right? So it's effective, and in data science, converting your data to an array makes it really, really, really cool. Again, one of the things that it helps it helps to do very powerful analysis. Helps to do powerful analysis. Yes. It makes for like it can hold different data types, hold different data types, but it only sees them as one data type. So which means it can take text and convert it to one data type. Yes, into one data type, which makes it easy for it to just read through and all. And you can make changes to them, make easy changes with array. easy changes, easy changes and modifications, easy changes and modification, mathematical operations and all that. So all these things are are really cool, right? And then so that's like one of the things. There are many things you can do with it, but one of the things you can basically get to do with NumPy, right? Again, every time you want to make use of NumPy, you have to import NumPy as MP. So to use, you have to import NumPy as NP. That obviously you can also choose to figure out which NumPy version you're working with. So you can basically say NumPy dot. So this is Donda, which is a magic distance, a magic Donda method, and it will basically tell you. Okay, let me not use this one. Let me use MP. Tell you the recent the version. So I'm using NumPy 1.235, and again, if I come here and type NumPy and there's a documentation, you can see the documentation here, and the documentation helps you to get to make sense of what it is. Another thing that that I love about NumPy is the fact that it has a representation of a whole lot of mathematical it has mathematical representations. You want to do a range of linear algebra, quadratic equations and all of that. NumPy can help you do that. Also, NumPy helps us to generate data. So this one is really, really important. Helps for data generation. Data generation, really cool stuff. Sometimes you're looking at you're looking at say you want to generate data from say maybe 0 to within, maybe generate random data between 0 and 1. NumPy can do that. So that's really cool data generation, especially numeric data generation. So NumPy is big on that too. So yep. So also Pandas is built on NumPy. So yep. So just know that. So a lot of the things you see that is happening here is just so you know, right? NumPy is built on that, and it just makes for such an interesting thing when working with that. So yeah, so let's look at a whole lot of stuff that you can do with NumPy. Okay, I opened the reference guide, which is one place that you would love to read through. There's a user guide, all of them say all the manuals. Let's look at this documentation from here. Right, there's a PDF version, and there are API references. That I told you. NumPy is a package for scientific computing in Python. It is a Python library that provides multi-dimensional array objects, various derived objects such as mask arrays and matrices, an assortment routine for fast operations on arrays, get me, including mathematical, logical, shape manipulation, sorting, selection, input output, Fourier transforms, basic linear algebra, basic statistical operations, random simulations. See this? You can do a lot of random simulations. In mathematics, there's a lot of random simulations just to bring up ideas and proofs. Right. So again, for the absolute beginners, I'll recommend that you guys look at this. For those looking at for reference guides, You can see all that for the absolute beginners. If you read through this, install, and then you can see different things you can do, right? You can look at them. You can do a lot of stuff with them. You can see again, NumPy arrays often look like lists, but they are entirely different from lists. In fact, there are things lists can do. In fact, you can convert a list to an array, which makes it really really cool. So so it's basically that. So a lot of the stuff that you can do with NumPy and the advantages that NumPy have, it's so so much. So let's look at a little bit of some philosophy. Say we create, so tells you the kind of things that NumPy can do. Say we have say we create page, and inside we have say 23, 5, 65, 21, 16 here. So yeah, so here this is what we have. Array. Now we now say that we now have, say, what do we want to look at? We now have maybe another one, say say number underscore trips, and then we want to say maybe number underscore trips is an array filled with the number of time each of these individuals have traveled. So first person has 4, second person has traveled 12 times, one person, this guy's traveled 5 times, this person has traveled 3 times, and then the last person has traveled say 12. And so we say, right, we want to do a mathematical operation on these two things, especially on this one. Say number has got trips. Want to do a mathematical operation on them. Basically, we want to say that when we're looking at the fact that we want to multiply, say, age times age times the trips divided by 2. You see, what was that? Oh, sorry, it's not like trips. Sorry, non-trips. So you can see, I mean, okay, you can't multiply a sequence by this. Okay, let's say we decide let's divide it, right? So we divide it and then maybe double it by this. Again, you find out that these things are very hard to work out, right? And so, and you're asking why isn't this possible? Because if you can see that if we look at age in itself, they're all lists, but what if I decide to do sum, open bracket, age, it's just going to give me this, right? What's going on? If we say norm underscore trips, it's going to give me 36. So why is it that with all this we're finding it difficult to do this kind of stuff? Of course, sometimes these are like limitations you have. You get me, with lists and integers, right? You can't really do that because they are lists and all that. But this is where NumPy comes to save the day, right? So now the first thing we do when we now have NumPy is that with NumPy, we can basically call this np underscore age, and inside we are going to convert age, we call it, to an array. When we open it, we put age inside. Same, oops, what did I do? And same thing, we can now say np underscore norm trips. And inside again, we say np dot array, and inside we have norm underscore trips, right? And so we run this. Now, when I now decide, okay, so here we have np underscore age. So now we have an array. See that? In fact, we just basically use type and then np, boom, we have the numpy array, right? And so with this, we can basically decide that now I want to np underscore age divided by np underscore trips, right? So, and boom. As a matter of fact, it even opens them up and then gives you everything in arrays. So see how fast NumPy does that. So NumPy really does a lot of this stuff, makes it pretty easy for you to do a lot of numerical operations, right? A lot of numerical operations in with that. So I mean, so you can see that it's just another thing that makes it really cool. Again, when you convert, for instance, say I have a list, right? Once you put anything in NumPy is really quick immediately to convert it into into different stuffs. It can convert whatever you have inside. But one thing NumPy does is, if you have, let's say we have a list, say we have a list, I say list underscore, let me call this objects. And inside them we have let's say we have Pablo, and we have 35. Then we have what else do we have? We have true. Right. So now I can convert this. So, and of course you see when you say lists and then you're trying to you're looking at the things that you have inside of it. You're trying to look at what you have inside. You probably see that its data type is a list, like the data type. If you want to find out, can we use that to find data type? Then you can find the type. It tells you it's a list. The list underscore obj, right? And now once we now convert this to an array, so we call this list obj underscore array, and inside we now say np the array open bracket lists obj, and we try it. Then when we type list obj array, you get to see that it tells you it's data type already. It's this, there are different types of data types, and this data type is, it looked at the first guy, right, and tried to convert its data type. It's, and we're going to also share the different data types that NumPy has. It has a ton of data types. So with it, a lot of things can be done with it. You can manipulate your arrays in different ways, right? So this is just an intro into what it's that you can do with NumPy, but there's a lot you can do with it, because it only contains one data type and all. And also it is always interesting how it's always interesting how arrays are when you literally want to once you want to work with them, they kind of, because they have different types of behaviors, right? They act in different ways, different from a list. So for instance, how do I show this? Okay, for instance, let's look at let me call this areas behaviors of I'll call this area as numpy behavior. And then, so check this. This is another one again. I think we have list underscore trips, right? So we have, no, what did I call it? List age. I think it's age, right? Right. So we have age, and then we now say plus. We now say plus list num underscore trips, right? What happens? You took two lists and added them. So they just came side by side and added them, age and this by the side. Now we created MP age plus MP. You see what happened there? They act different. Different. So when you do this, these guys come side by side. But when you take an array, you see the addition is happens once. So you have 23 plus 4, 27, 45 plus 12, 57, 65 plus 5. You get me? Look at that. This is how this works with an array. So they're like matrices, different. They just have a way they don't stay on the side. It feels like they're stacked on each other. They just stack it on each other really quickly. And they are more magnitudes of they're fast. When you run, when if I was to put a time it here, did I get it right? Yes. So you put a time it here, you can see that if I put time it here for an array, time it, yeah, definitely time that two of them do stuff is, you know, it's try as much as you can. Oh, I wasn't even supposed to share them in this way. They're supposed to be in different this thing. But what happens is when you use the timing, I didn't get this correctly. When you use the timing for them, they'll show the speed at which two of them do their calculations are entirely different. I'm going to figure out how to use that, but it's entirely different. The speed for each of them is crazy. Um, so again, you can also create Python arrays from this. They are right? So I mean, once you find, there are always ways you can basically time your whatever it is you're running. Once you time whatever you do, it's supposed to check the timing and then let you know how. I'm beginning to wonder if I didn't get this correct. That's what I'm trying to see. I'm trying to understand why they're different. One is supposed to check the other, but once I check that out, I'll show you guys how they work, how the speed of one over the other, right? So you find out the speed of one over the other. You see like the magnitudes of speed and how one works and why the other is slow and why others are faster. So yeah, but yeah, I think I'll figure out that. I'm not using it the correct way. But yeah, so bottom line is, these guys are faster when they are used. When you are using NumPy to run stuff, they are faster. But for lists and the rest of them, they're a lot slower. Which other thing can they can? There's a lot that can be done. It's you can read through, you can index, NumPy arrays, and it's like MPH, they can be indexed. Get me just like those guys, they can do basically a lot of the stuff that you can do. So yeah. And also with arrays can come in 2 dimensions, right? Which they can also come in 3, 4 dimensions and all, which is also so important. What that means is your data can be stacked on top of each other, and also that's another massive thing that NumPy arrays can do. They can stack data on top of each other, and then they will be in arrays. And you can have 3, 4D arrays, and I think 3, 4D arrays are called tensors, and they are really magnitudes of their speed, and they're really quick when you do analysis with them. You can convert numbers, you can convert photos and unstructured data into arrays, and pictures can be converted into arrays, manipulated, and returned back to those pictures. So you see how fast those things can work. Yeah, so NumPy is it's really huge. As we proceed, we're going to see how you can also use NumPy for data analysis, and which makes it really fast. Because for the most part, you are trying to optimize for speed instead of optimizing for you're trying to optimize for speed and for some of your analysis that you're doing. And yep. And so and that makes for a lot of stuff, a lot of, because when you optimize for speed that way, then you find yourself having to do a lot of things quickly. Yeah, so those things are like that. So again, many things you can do with um with NumPy. You can create arrays, like you can create arrays from scratch, which is you can choose that you want certain kind of numbers and you can use them. Like I told you, the part that I talked about is generating data. See this type here, data generation. NumPy has NumPy has it has functions that can help you do that. For instance, let me see. There is a NumPy np dot. It's np dot random dot random. There are so many. So like this, what this does is it can return random floats in half open intervals, like 0.1 to 1, right? You can have that. You can have random. You can say that you want a random number, say from 2 to 4. Yeah, what did I get wrong? Oh, sorry. We can 2 to, yeah. And so you can just generate these random numbers, and you can say you want, so what we have here are 2 rows and 4 columns, right? And then you can just generate random numbers like that. And so it does that. It really tries to set that up. There's mp.arange, just like range. This one, just like the range, this one returns evenly spaced values within a given entity. You can have a start, you can have a stop. You get me? You can have a start, just like range. You can have a start and you can have a stop, and it will do it, but it does it faster and it brings them out in arrays. And you can also create arrays and use them to do visualizations, which is huge. That's a lot of stuff that NumPy can do. So NumPy can do it. Do these? Yes, exactly. They do. They work as vectors and matrices. Yeah. Yeah. So that's basically that. There's a lot that you can do with NumPy. You can subset with NumPy. You can do a lot with NumPy. You can slice with NumPy. You can do statistics with NumPy. You can do a lot of things. You can sort with them. You can, so many things. You know, for instance, let's look at, say, let's look at this. Say we want to check for people's height, for instance. We want to check data for people's height. Say we realize that there are people who are within, let's say within say there's height, and these people we want to get people to have certain generate random data. And so we're going to use, like, say, random dot this random dot normal. This one, it draws from a sample of a normal distribution, right? And say what I want to do is I want people who to draw a random setup for people who are within 6, maybe 5.11. Oh, sorry, 5.11, right? And 6.3, right? And I want to generate that number for 500, right? Then if I check height, I have an array. You can see that, like, you can see it will just generate all that numbers. Like, it's crazy, right? The one that works most is, let's say, if we want to generate it, say people's height, and we're checking it in meters, let's say 1.75, and then we're checking to maybe 0.20. Yep, we can pick that up, and you can see heights, look at heights, right? And then you can see the difference in all of it. It's a lot of generations. Look at that, 500. And so we can choose that these are people. We have 500 people who are within a certain height range, right? It's really important. Just imagine you're trying to do an analysis, and the analysis is that we need to analyze the height of 500 individuals who are within 1.75 meters to 2 meters. How are you going to collect that? You can just, and what NumPy does is that it generated this using a normal distribution. You get me? So that's what it did. It derived it from a normal distribution. Like, and the normal distribution is basically 68% of the height you're seeing there. 68% of them are are within the one standard deviation of the mean, right? So which is classic. Like with this, you can, even if you say if you're trying to find the mean of the height here, you get me, you see that 1.76, like 68% of the of this distribution of it are within 1.76. So very cool stuff when you use NumPy. You can use NumPy to generate data. You can choose a lot of, you can do a lot of things with it. That's why it's really so important that you guys check out this, you know, read up on this, especially this part for absolute beginners. Really cool for you to understand them. Here, you get to see how they are created, what it means, the different types of things you can create with it. The arrays, you can create the representations for each arrays. You can add, remove, sort elements in arrays, different stuff. You can do a lot of stuff with it, right? Yep. So really cool stuff we can do with NumPy, and it's really fast. I'll also advise, you can also read up NumPy maybe through articles, but I think, did I share a book with you guys on that? I think I did. But yeah. So that's basically just an intro to it. So that's just the intro to this. So that's just basically the intro to this. So yeah. Questions? Do we have questions? It's 2 more minutes to go. Two more minutes. Any questions? No questions? Today is what? Today is 3rd. Are you guys done with your assignments? All right. So by the end of today, so I probably have to announce that the people should submit their assignments, and before people say, Esther, why are you laughing? You said you're done with assignments. There's something I'm missing. So first assignments. Thinking people should have tried. So it's day 16, just 16. Just 16 folks. Why do we just have 16 folks who have done this? I mean, is it that like a lot of people don't know this? Is it? Aren't you guys in learning circles? You guys are in learning circles now. Have you guys been broken into learning circles? Esther, you are a learning circle lead for last semester. Are you still a learning circle lead? You're not. Are you guys going to be putting? Okay. She says she isn't. Oh, there's an election. Oh, interesting. Nice. Mika. So, no, so yes. So apparently, so once that's it, because I really need you guys to for us to get this assignment done. I mean, it's interesting that we haven't gotten this assignment done. What's holding it? Hmm? What's holding the assignments from happening? I don't see Tawakali to here. Tawa, what's going on? Tawa, what's good? You've not submitted your assignment yet. Yeah, sure I will. Please don't do last minute type stuff so you don't be rushing and all. Before 10 p.m. All this last minute things. So your brains are saying last minute. So you now invoke last minute things. And you start. So come on, you guys should try and it's not that deep, no, it's just the simple stuff. You guys need to like normalize that so that not when it's time for your assessments, when you need to write articles and post articles, then you're all like, oh, we're all over the place. No. So please try. Let's get this done. Now we should have a lot of these articles here. It's not simple, Esther. How you say it's not simple? Why would you say that? No, it is. So please let's try as much as we can to submit this so that so we have so this makes up your part of your continuous assessment. So a lot of you don't come in later and start saying, oh, look at the scores we're having. Scores are not much. We need it to be reviewed. Someone comes and say, I could not have scored this low. What did all my 32% go to? So no, that kind of thing. We don't want that kind of stuff again. So right, yes, you know yourselves. So please, it's not tricky. Other, it's not. Yeah, it's not tricky. So no. So yeah. So let's try. Let's try. It's not. The assignment is basic. In fact, let me even look at it so we can assess this assignment that is tricky. It's not tricky in any way. What is this first assessment? How is this tricky? I have two different. Then do it. Do your interpretation. Write it down. Right? Write it down. Please do correction. Oh, is it? How do I do corrections? Download this data set, read it into a data frame, display the first 5 rows. I'm not doing any correction. I'm just basically showing. Print a concise summary of the data frame. Right. Simple. This happens all through. Display from the second question. Display from the second question, right? The display from the second question will show all the columns have identical data types. Fix this by converting the column data types appropriately. Well, the data type should appropriately fall within the categories qualitative, discrete quantitative, and continuous quantitative. 3. So what the number 3 means is data types have so I need you guys to go and read up on different categories of data types and build upon this: qualitative, discrete, quantitative, continuous, quantitative, and you see what it means, right? There are different types of data types there. Now, what I'm doing is I'm pushing you guys towards the statistic sides of things. So once you guys look at that, then you're now going to start checking out your data types and start looking at it. Yeah. No, it's not that. I'm not explaining anything. So just check it out. It's basically the same thing that is here. Data types should fall within the following categories. Yeah. So it's not about that. People are yet to submit. I'm not even saying anything. I'm basically repeating what is here, right? So do it. It's read it up. I just need you guys to do some thinking. Right? Think about it. It's pretty simple when you think about it differently, right? So that's that. So let me